In this video, we'll understand reinforcement learning from human feedback, or RLHF, in a simple step-by-step way. We'll see what it means, how its three-stage workflow operates, where it is used, and what its benefits and limitations are. And yes, we'll pause in between with short quizzes so you can check your understanding. RLHF stands for Reinforcement Learning from Human Feedback. It is a training approach used to align machine learning models, especially large language models, with human preferences and values. Instead of depending only on fixed rules or labeled data, the model also learns from human ratings, rankings, and evaluations. The main goal is to make AI outputs not just accurate, but also helpful, safe, and closer to human intent. A model may generate technically correct answers, but still miss what people actually want. That is where RLHF becomes important. It brings human judgment into the training loop, helping the system understand qualities like usefulness, politeness, safety, and factuality. In simple words, RLHF helps AI behave in a way that feels more aligned with human expectations. In the first stage, a large pre-trained model is adapted using supervised learning. Human experts provide high-quality prompt and response pairs, and the model learns from these teaching examples. This helps it follow instructions better, produce more relevant outputs, and reduce random or undesirable behavior. Think of this as the grounding stage before reinforcement learning begins. Now, let us look at this in a simple table format. RLHF workflow stages. The three main steps in training with human feedback. The RLHF workflow usually happens in three stages. First, supervised fine-tuning teaches the model using expert-written examples. Second, reward model training converts human preferences into a reward signal. Third, policy optimization improves the model so that it produces responses that score better according to that reward model. In the second stage, the model generates multiple responses and human evaluators compare or rank them. These rankings capture subjective human preferences like which answer is more helpful, safer, or more factual. A reward model is then trained on this feedback. Its job is to assign a numeric reward score, so future training can use this score as a proxy for human judgment. Now that we've covered RLHF basics, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. What is the main goal of RLHF? The correct answer is to align AI with human preferences. RLHF is mainly used to make model behavior better match human values, preferences, and intent. Question 2. Which stage of RLHF uses expert prompt response pairs? The correct answer is supervised fine-tuning. Supervised fine-tuning uses human-created examples to teach the model how to respond properly. Question 3. What does the reward model learn from? The correct answer is human rankings of outputs. The reward model is trained using human comparisons or rankings of model responses. Now comes the reinforcement learning part. In policy optimization, the model is updated to generate responses that maximize the reward predicted by the reward model. A common algorithm used here is PPO, or proximal policy optimization. PPO helps keep updates stable and controlled, so the model improves gradually without making large risky changes that reduce quality. RLHF is not limited to chatbots. In autonomous driving, the system can first learn from large datasets and simulation-based reinforcement learning. Then human drivers and safety experts evaluate decisions like lane changes, speed control, and reactions to unexpected situations. Their feedback helps refine the reward function, making the system safer, more comfortable, and more reliable in real-world traffic. RLHF has many practical applications. In chatbots and conversational AI, it helps models generate more helpful and context-aware replies. In content moderation, it helps systems learn human judgments about harmful or inappropriate content. In recommendation systems, it improves suggestions using user feedback. And in autonomous vehicles, it supports safer and more human-like decision-making. Now that we've covered workflow uses, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. Why is PPO used in RLHF? The correct answer is, to keep training stable, PPO limits large updates and helps policy optimization remain stable and reliable. Question 2. In autonomous driving RLHF, human experts may evaluate. The correct answer is lane changes and speed decisions. The article mentions decisions like lane changes, speed adjustments, and responses to unexpected situations. Question 3. Which of these is an application of RLHF? The correct answer is content moderation. RLHF is used in content moderation to improve judgments based on human reviewer feedback. RLHF offers several advantages. It makes AI systems more adaptable because they can improve through iterative feedback. It is human-centric, since it directly includes human intuition and expertise. It also supports context-aware decision-making, which is especially useful in language tasks. And because the learning is guided by real human preferences, models may generalize better across different tasks and situations. At the same time, RLHF has limitations. If human feedback is biased, the model can learn and amplify that bias. The reward model may not perfectly capture what humans actually want, so the reward signal can be imperfect. Also, expert feedback may be limited in specialized domains. On top of that, RLHF is complex to implement and often slow and expensive because it requires repeated human evaluation and retraining. Now that we've covered pros and cons, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which is an advantage of RLHF? The correct answer is improved adaptability. The article lists enhanced adaptability as a major advantage of RLHF. Question 2. Which is a disadvantage of RLHF? The correct answer is bias amplification. Biased human feedback can lead the model to reinforce those same biases. Question 3. Why can RLHF be costly? The correct answer is it needs repeated human evaluations. RLHF is resource intensive because humans must evaluate outputs and the model often needs retraining. That's it for this lesson on reinforcement learning from human feedback. If you understood the workflow and could answer the quizzes, you already have a strong foundation. Keep learning, keep revising, and I'll see you in the next video.